Derivation of the laws of what? Logarithm part 4. Of course, this has to do with the derivation of the fourth law of logarithm. The fourth law of logarithm. Theoretically speaking, the fourth law of logarithm states that the logarithm of what? A number, say what? A, in this case, to a particular base, say b. That is, the logarithm of a to base b is defined as what? The ratio of what? The log of the number, which is log a, to what? The log of the base, which is what? Log b, or to what? A new system with a different base. Let's express this mathematically. When we do that, we have the log of what? A to base b is as good as the log of what? A, are you there, to a new base divided by what? The log of what? B towards a new what? Base. This is called the third law of logarithm. Our task in this particular video is to see to the derivation of this particular law, validating that indeed the log of a to base b is log of a to a new base divided by the log of b to what? A new base. To do this, we are going to be representing the logarithm that we intend transforming with what? The alphabet y. So let what? The log, or let either the log of what? A to base b be equals to what? Y. Let us represent the log of what? A to base b as y. If that is true, going by what? The definition of the logarithm of what? A number which is defined as the power to which the base must be raised, which in this case is y, in order to obtain what? A. This what? Expression could be reinterpreted with the exclusion of what? The log. So we have this expression to be what? A is equals to b raised by what? Y. I will call it equation what? Number 1. Now going further, let us what? Say x, or use x to represent the log of what? The number now, which is what? A to the new base. So in that case, we say let what? X represent the log of what? The same number, but to the new base that we are we intend what? Interpreting the new what? Value what? Is. Wait, rather, let what? S be equals to the log of a to base what? M. Now when we do that, we'll call it equation number what? 2. Now, the next line of action is to put equation what? 1 into equation 2. What does that imply? It implies that wherever we see what? A in equation 2, we can put in b raised by what? Y. If we do that, we're going to have x is equals to what? The log of what is a standing for? B raised by what? Y to base what? M. Now, there's a law of what? Logarithm, which I just what? Derive in what? Part 3. I told you that what? The logarithm of the n power of what? A number, say what? The log of what? A raised by n to a particular base, which is what? B is as good as what? The power, that is n, times what? The log of what? The number, which a in this case is used to represent. Go to part 3 of the derivation of the laws of what? Logarithm. You see how it what? Originated. Now going by that particular law, this y becomes what? A multiple to this. In other words, we now have what? X is equals to what? Y, the log of what? B to base m. And I will call it equation number what? 3. At this point in time, we shall be making what is called y the subject of what? The formula. Let us now make what? Y the subject of what? The formula. When we do that, we're going to have what? Dividing all through by what? Log b to base m. We have what? X all over what? Log b to base m is equals to what? Y, the log of what? X, divided by what? Y, the log of b to base what? M, all over what? The log of what? B to base m. So this, we strike this. What is left is just y, and that y is equals to x all over what? The log of what? B to base what? M. The question now is, what is x standing for? Don't forget, it's still on the board. S is used to represent the log of a to base what? M. Implying that anywhere I see what? X here, I'm going to be putting in or substituting in log a to base n. So let's do that now. We have what? The y is equals to the log of what? A to base m divided by the log of what? B to base m. Therefore, are you there? Y is equals to log of a to base m divided by log of b to base m. So what is y actually standing for? Let's go back to the original what? Interpretation. I said let us use y to represent log a to base b. So imply that wherever we see what? Y in this particular expression, we're meant to put log a to base what? B. Doing that, we have what? Therefore, the log of what? A to base b is equals to the log of what? A to base m divided by the log of what? B to base m, which again validate the authenticity of what? The fourth law of what? Logarithm. Please do not hesitate to like, to share, and of course comment. Look forward to what? The derivation of the laws of logarithm part 5, and that has to do with the derivation of the fifth law of what? Logarithm. Love you.